AB Calculus Note Card 47, Related Rates, Change in Variables. This is the 47th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. With this 47th lesson, we are pretty much through what we would call differential calculus in our calculus course this year. And from here, lesson 48 on is going to be mostly concerned with what we would call integral calculus. Use this method usually when some rate or ratio is given for one variable in the problem. And the particular instance here we're going to explore is where we are given two variables. And with two variables, as far as two independent variables that are changing at the same time, it is immensely helpful if we can get one of those variables in terms of the other. And so this is a level of complexity that exceeds what we looked at in the lesson for Note Card 46. But initially in the setup, it's all similar. First of all, we determine what we're going to find, when, given, and then we are also given an equation. So in this respect, things are similar. We're going to start out the same way, which is going to be to draw a picture. And we have an inverted cone, has a height of 9 centimeters and diameter of 6 centimeters. So we draw this cone, this inverted cone, and we have a diameter of 6 centimeters. And we have a height of, I'll put over on this side, of 9 centimeters. That's going to be our height here. And one thing that's going to be helpful to us in this is with a diameter of 6 centimeters, our radius is going to be half that, or 3 centimeters. It is leaking water at a rate of 1 centimeter cubed per minute. So here we have a leak coming out of the cone, and the rate's going to be 1 centimeter cubed per minute. And with the leak, do you notice I put -1 centimeter cubed? Yes. Find the rate at which the water level is dropping when h equals 3 centimeters. And so we have an h here, which would be the current water level, and that's going to be 3 centimeters. 3 centimeters. Okay, and then we're trying to find the rate at which the water level is dropping. So we're going to call this dH dt when h is equal to 3 centimeters. We are given dV dt, or change in volume, is equal to -1 cubic centimeter per minute. Okay, now we're also given, as far as the shape of the cone, we have the height of the cone is 9, and the radius is equal to 3, and these would be centimeters in both instances. And we're given our equation, and typically for this type of equation, they'll actually give it to you in the test. They wouldn't, for some reason, expect you to know this. So we have two variables on the right side that are changing at the same time. And so that's going to be a little bit tougher to deal with. So what we're going to try to do is get, instead of having two variables on the right side, just one. And there's a relationship where our radius over our height is equal to 3 over 9. And so that's going to simplify to R over H is equal to 1/3. And to solve for R, we can cross multiply the H, and so we're going to have H, I want to put R, excuse me. We have R is equal to H over 3. So that's a ratio, and with this ratio, R equals H over 3, we're going to plug it in for this R here, and thereby reduce to only one variable on the right side. And so bringing down, we have V is equal to 1/3 pi, and then we have, in the place of R, we have H over 3, and we continue to square that, and then we have H, and that's what we have. And now simplifying, we're going to have V is equal to, now we're going to have pi in the numerator, and we have H squared times H, or H cubed. And then in the denominator, we're going to have this 3 times this 3 squared, which is going to be 27. Now we're going to differentiate both sides with respect to time, and for that we get on the left side dv dt, and on the right side we're going to get this h, this h cubed is going to be 3 pi h squared, and we have dh dt, and we maintain our 27 in our denominator here. And now we're in a situation where we can start plugging in and solve for what we're trying to find, which is dh dt. So we're going to substitute -1 for dv dt, and on this right side, this 3 over 27 is going to simplify to 1/9, and so I'm going to so that we're going to just write pi, and we're going to put 9 in the denominator, and in the numerator we're going to put in our value for h, which is 3. So we have 3 squared, and that's going to be dh dt. Now our 3 squared in the numerator would cancel out this 9 in the denominator, so we're going to get -1 is equal to pi times dh dt. And working to the right to solve for dh dt, we need to divide by pi, so we're going to get -1 over pi, and then our units are going to be centimeters per minute. And that will be our answer. Again, to summarize, we were able to combine these two variables R and H into one to make this a whole lot easier for us. And I hope you can see that we're using the same concepts we used in the Notecard lesson 46, but with this tool of substitution to deal with this added complexity. Again, I encourage you to look at my video lesson series of related rates problems. There are 7 of them, one of which is another cone volume type problem. I hope this has been helpful to you. As always, good luck, and thanks for viewing.